Welcome to Intro to Factoring. In this video, we're going to cover how to factor by greatest common factor, difference of two squares, and trinomials without a leading coefficient. So the first one we're going to go over is factoring with a GCF. So what you're going to do is you're going to try and find the largest monomial that divides evenly into each term. In other words, what is their greatest common factor? If you look at the coefficients here, I have 3, 9, and 12. Out of 3, 9, and 12, the largest common factor that goes into all three is the number 3. Then you're going to look at your variables. X, Y, and Z have nothing in common. So in this case, my GCF is just 3. What you're going to do is create a set of parentheses. And on the outside of the parentheses, you're going to write the GCF. Then, in order to get the inside of the parentheses, you're going to divide each term by the GCF. 3x divided by 3 is x. 9y divided by 3 is 3y. And 12z divided by 3 is 4z. And that's your answer. If you were to distribute the GCF back in and, multiply the 3 back in, you should come back to your original expression. For the next one, let's find the GCF. If you look at the coefficients, 2 and 2 have a 2 in common. If you look at the variables, they both have x's. You do have to think about how many x's to take out. When you're wondering what the GCF of variables is, you're always going to go with the smaller exponent. So in this case, the smaller exponent is 1, which means my GCF is 2x to the first power. So, for example, just to clarify, if you have x to the fourth and x cubed, the GCF of these two terms is x cubed because 3 is the smaller exponent, right? If this one has 4 x's and the other one has 3 x's, the greatest number of x's that they have in common is 3. Anyway, once you find the GCF, you're going to write the GCF on the outside. And you're going to open a set of parentheses. Divide each term in the expression by the GCF and write it inside the parentheses. 2x squared divided by 2x is just x because the 2's divide into 1, and x squared divided by x is just x. The next one, negative 2x divided by itself, will give you negative 1. And that's your answer. So factoring with dots, please write this down because a lot of people don't know what dots represents. So dots represents difference of two squares. Basically, you know if you can use dots if, first of all, you have the difference. You can't do this with a plus sign. You can only do this when you see a minus sign. And if you have two terms, right? If you have 3 terms, that's not good. And if both terms are perfect squares. So you're first going to check to make sure if you can use dots at all. In this case, we have the difference, which is good. We have 2 terms, and both terms, 4 is a perfect square, x squared is a perfect square, 9 is a perfect square. We can use dots because it literally is a difference of 2 squares. In order to do this, you're going to set up 2 parentheses. You're going to put a plus in one and a minus in the other. And you're going to take the square root of both of them. The square root of 4x squared is 2x. The square root of 9 is 3. And you're done. If you want, it doesn't matter which order this comes in because of the commutative property of multiplication. you can write this as 2x minus 3 times 2x plus 3. So whether the plus comes first or last, I don't care. Same thing. Let's try another example. 25 is a perfect square. X squared, x to the 6th is actually also another perfect square. And we're taking the difference of them. So this works for dots. One's plus, one's minus. The square root of 25 is 5. And now you have to find the square root of x to the 6th. When you're trying to find the square root, all you have to do is divide the exponent by 2. So in this case, 6 divided by 2, 2 is your root, right? Because we're taking the square root. We are going to get 3. So I took my exponent, divided it by the root that I was taking, and you get your new exponent. So I have x cubed. The square root of x to the 6th is x cubed, and you are done. And now we're going to do the last method, factoring trinomials without a leading coefficient. So trinomials means 3 terms. You can only do this with 3 terms. And you need to make sure that the leading term has a leading coefficient of 1, right? If you had 2x squared plus x minus 20, this would not work. You might also know this as the AM method. Because we can factor this since it's a trinomial without a leading coefficient, you're going to find 2 numbers that add to the middle term of 1 and multiply to the ending term of negative 20. So what adds to 1 and multiplies to negative 20? And your answer to that is positive 5 and negative 4. And think about it. Positive 5 times negative 4 is negative 20. Positive 5 plus negative 4 is positive 1. So you're going to take those 2 numbers that add to 1 and multiply to negative 20 and write it in the parentheses. Now what goes first is you have to take the square root of the first term. So if you have x squared, that's going to be x and x. You're splitting them up evenly. And you're done. We're going to try another example of this with b squared plus 9b plus 14. You want 2 numbers that add to 9 and multiply to 14. You're going to take the variable that comes first and you're going to split it up evenly. Now, your 2 numbers that multiply to 14 and add to 9, that's going to be positive 7 and positive 2. 7 plus 2 is 9. 7 times 2 is 14. If you are having trouble with figuring out your plus and minus signs, you could read the notes above, and it tells you a trick to how to make sure which one's positive and when something is negative. Also, keep in mind, if this were to be, as an example, let's say you had b to the 4th power plus 9b squared plus 14. This is pretty much going to be almost the same with respect to the plus 7 and the plus 2. However, the difference is because we have the b to the 4th, you're going to split the b's up evenly into both parentheses. So if you take 4 b's and you split them up, now you have 2 b's. So this is going to be b squared plus 7 and b squared plus 2. And that's all for this video.